My name is Stephen Ansari. I'm a principal and co-founder at Blue Raster. My background is in earth science, and for the past 20 years, I've used spatial technologies to understand and solve complex global problems for companies and governments around the world. We at Blue Raster are very excited about the innovations in Earth monitoring tech, measuring greenhouse gases. Bill introduced the Sentinel-5P satellite, launched by the European Space Agency late in 2017. On board, it has a tropospheric monitoring instrument, called TROPOMI for short. This platform has been delivering daily measurements of greenhouse gas observation. This is currently the most detailed methane emissions monitoring available at a global scale with a resolution of about 50 square kilometers, or roughly 7 by 7. The sensor platform flies 824 kilometers above the Earth. It circles the Earth in a near-polar, sun-synchronous orbit so it can cover the entire planet each and every day. Here you can see data compiled for a single day across North America. As we zoom into the Permian Basin in Texas and New Mexico, you can see the resolution of the data will not identify particular sources of methane. But having a low-cost daily picture of methane anomalies across the globe and within the basin is key to understanding patterns and cost-effectively investigating further. Looking at the spatial temporal data geographically, you can visibly see specific event anomalies across space and time. I pointed out a few on this graph. Some last for a few days, and others are persistently showing higher concentrations of methane over time. Seasonal and monthly summaries of these anomalies invite conversations, and the analyst immediately begins to develop additional research questions. Let's drop down to a 3-day lens and look at the basin over time. These are not canned reports. These are interactive maps with access to historic as well as data recorded just a few days ago. We are unlocking the full potential of Power BI dashboards by including ArcGIS reference layers like this one. This empowers our users to visually see relationships and patterns across many parts of the puzzle. We can organize the analysis results using a uniform grid to provide meaningful clarity. Now you can operationalize the results into action by saying, this problem or this issue covers 600 square miles. We're now going to go behind the scenes and walk you through how we use Microsoft Azure and EsriUC Enterprise to automate the workflow. From raw data to Power BI dashboards, ensuring that the latest data is available to the dashboards is the key to making use of, as well as making sense of, the abundance of data. The TROPOMI data is available via ESA's Open Access Hub. The raw formats are hidden away in a binary scientific data format called netcdf. At the hub, you can search for the area and time of interest and download raw files for more advanced use. Using the Data Explorer, you can visually see the arced path the satellite takes, as it must orbit the Earth many times to cover the entire planet each day. We will be sharing material via GitHub, as well as Python notebooks to help others recreate our workflow. The automated workflow leverages European Space Agency's Data API to access data as it becomes available. From Esri, we take advantage of their rich Python API for ArcGIS. This is connected to Azure Storage to extract, harmonize, and combine all of the raw data sets from the satellite into a unified grid of GIS-ready data. Careful attention is paid to maintain data fidelity with the source. I'm going to use the new Python notebooks for ArcGIS to demonstrate how we build our mosaic dataset and the summary reference layers that will later be used in the Power BI dashboards. Once the data is downloaded, the first step is to access and unlock the specific dimensions and attributes needed from the binary netcdf file. These comprise of coordinate pairs and methane values. But due to how Sentinel travels over the ground, measurements directly below the satellite are closer together than those at the edge of each pass. we have to reconstruct the specific area on the ground that represents the measurements recorded. For each point to properly maintain a meaningful coarseness that reflects the true uncertainty of the measurement. Here, you can visually inspect alignment, and you will notice the rectangular shapes vary in size from east to west. Now we have normalized methane data over time for our area of interest. This reference layer will be key for the analyst exploring the data in the Power BI dashboards. For the decision maker, however, we can now overlay our summary level hexagons and derive a high-level executive reference layer. This will more quickly bring to attention the greatest anomalies across the basin. These layers are published daily into ArcGIS Enterprise and would even work with ArcGIS Online. Now, let's pivot over into Power BI. The magic of this endeavor is bringing together lots of data into meaningful Power BI dashboards. Infrastructure features like pipelines and wells, production data, reported accidents and known leaks, as well as wind data and other impactful conditions over time. I'd like to now invite Shannon Lindsay, our Senior Power BI Specialist at Blue Raster, to share just how all of this comes together. Shannon?
If we are interested in looking at both production data and methane data together, this first report page is a nice place to start. What you can see here is on the left-hand side, we've got our filter pane where you're able to slice and dice the data by date, by operator, by product type, by production value, and by average methane value. You'll then see in the center of the report page here, we have an Esri ArcGIS map. This is a custom visual for Power BI. And what we're doing here is we're able to view our own reference layers along with the data that is being populated from the Power BI report. You'll also see that we've added in here a nice line chart and we have some card visuals to help get the point across. So, for example, if you were looking at this report page and you see, okay, something is going on here between August and November to December, and we want to take a look at what exactly is happening. What we can do here is we can slice by date. So we can look between August, mid-August and January, and we can then pick a specific operator. So I see here an operator that stands out to me. I'm going to take a look at this particular operator. And then what you can see here on the map are all of the oil well locations that this particular operator runs that have a non-null production value. And you can also see the average methane in the atmosphere over the vicinity of the well on a given date. So what we're currently seeing here in the report is the month of September, and then again, we're seeing the production, which is the size of the bubble, and the average methane value, which is the color of the bubble. There is a built-in time slider in the ArcGIS custom visual that you're able to see. In some cases, if your data do not have any values for that month, you won't see them. But here, of particular interest, what you can see is we've got pretty across the board, we've got high production, so we've got these larger bubbles, and then we also have pretty high methane values, so looking at these dark orange values. So what we can see here is what particular well has this production value and this methane value. If you wanted to look at a different operator, you can slice and dice by different operators. You can see how many wells they have, and you're also able to zoom into the map so you can see what's really going on here. This report page is slightly different in that we are looking at methane values over time alone on the map. And what you see here in the ArcGIS map is that the colors associated with the points on the map are associated with the operators. So for example, if we wanted to look at one particular operator, You can see on the map here the location of all of their wells. And what you can see here is that the production for this particular operator has been increasing over time. And then if we'd like to look particularly at the methane data, it makes the most sense to look at this data by day. So the methane values are gathered daily by the satellite, and we want to take a look at potentially a particular day where we know that there has been a high methane value, and you're then able to look at this data and drill down and see, which particular well is associated with this data and what has been going on. You can also use this report page to compare two operators. So if you have two operators that you know are working in the same area, you're able to take a look at the production value of the well, and also the methane in the atmosphere. And we know that the methane in the atmosphere, of course, there's wind, methane can move. So you're able to just take a look at the presumed association here, and then you can really dig into it and see what's going on with that particular well, with that particular operator. To take advantage of the advanced mapping capabilities that are available to us via the ArcGIS maps for Power BI, we can simply, inside of Power BI, edit these maps. And what we're able to do here is we are able to add our own reference layers of content that we have created within our organization. So I'm going to go ahead and jump in here and search my organization for our pre-prepared methane data. We'll just give this a minute to load. And now what you can see here is we can go ahead and plot this reference layer. And you'll see here that it appears underneath the points that are being fed via Power BI. So this is really nice capability that exists. Now, if you'd like to take this a step further, we also have the ability to use some different ArcGIS capability inside of the web service. So if we're looking at Power BI in the web, you can see here, this is our Power BI report. This is what we've been working on. You're all very familiar with this at this point. We also have the ability to embed different ArcGIS content into our Power BI Explorer. And folks are able to use this content as well in addition to the Power BI reports. So we're able to really see all of the data that we need to see, both related to the data itself and related to the geospatial processing, all under one pane of glass. So here we're seeing both ArcGIS and Power BI reports right here in the Power BI service.
Thanks to Bill and Shannon for your help today, and to Esri for hosting. We'd love to engage in further conversations, so please reach out to us this week. Thank you very much, and have a great EsriUC.